direct PDF upload to Claude, 11.4 seconds average, 18 seconds at P95. Pre-extracted markdown with a cached system prompt, 1.8 seconds. Same invoices, same accuracy, 6 times faster. If you're building a customer-facing app on Claude and users are staring at a spinner wondering if the thing crashed, you already know what I'm talking about. I'll show you the exact pre-extract pattern that killed that latency in a live invoicing pipeline. Most tutorials chase accuracy or cost. Nobody talks about P95 latency, which is the thing that actually makes users abandon. I'm Lazar. I ship these pipelines for clients. Let's get into the slow part nobody warns you about. Here's the scenario. You built a tool. A user drops in a PDF invoice. Your app calls Claude, gets back structured JSON, fills the form. Clean flow. You demo it. Works fine on one PDF. Then a real customer uploads 10 in a row, and the whole thing feels broken. 11 seconds per request. 18 at the tail. Users assume it crashed and refresh the page. That's the problem we're solving today. Let me show you the actual numbers from a production invoice ingestion pipeline. I ran 240 supplier PDFs, Serbian invoices, mixed layouts, some with tables, some without. 2 paths. Path 1, upload the raw PDF straight to Claude with a prompt that says, extract these fields. Path 2, pre-extract the PDF to Markdown once, store the text, then send only the text plus a cached system prompt. Same model, same extraction schema, same answers come back. Path 1 averaged 11.4 seconds. P95 was 18 seconds. 0.95 with 18 seconds. Path 2 averaged 1.8 seconds. P95 was 2.6 seconds, roughly 6 times faster. The accuracy difference on text-based PDFs was inside the margin of error. So why is the upload path so slow? 2 reasons. First, when you send a PDF to Claude, the model has to tokenize the whole document on every single request. There's no caching benefit because the file payload is part of the user message. Second, PDFs are heavy. Even a 2-page invoice can be tens of thousands of tokens once you account for layout, fonts, embedded structure. You're paying the tokenization tax every time, even if the user is asking a follow-up question about the same document. Now here's the fix. Step 1. Extract the PDF to text exactly once, the moment it lands in your system. I use pdfplumber for this with a table-aware parser. pdfplumber is good because it preserves row and column structure, which matters a lot for invoices where the line items live in a table. You run extract doctext on each page, then run extract doctables and serialize those into markdown pipe tables. Stitch it all together into one markdown blob. Store that blob in your database next to the original file. Step 2. Write your system prompt once and structure it so it's cacheable. Anthropic's prompt caching gives you a massive discount and a latency drop when the same prefix repeats. Put your extraction schema, your field definitions, your few-shot examples, all of that in the system prompt. Mark it as a cache breakpoint. Now every subsequent invoice extraction reuses that cached prefix. Step 3. The actual call. If you're building a customer-facing app and PDF latency is killing the experience, this exact pipeline is the kind of thing we ship for clients at BizflowAI.io. Go take a look at real automations we've built for solopreneurs and small teams. Hit subscribe and ring the bell so the next breakdown finds you.